Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. Today we are starting last article of this chapter, which is nothing but what? Inverse trigonometric function. To understand this article, we should have to know what is the definition of what? Inverse function, when the function is called as inverse. And using this definition, we are able to study about what? Inverse trigonometric function. So let us revise once again the definition of what? Inverse function, which you have studied in class 11. But to understand the definition of inverse function, first you should have to know the definition of what? Function. So in short, we will revise the definition of function and inverse function. So consider here two sets are there. So we are trying to understand this definition by considering one simple example. Sets are denoted by any capital letter. Let us denote first set by E and second set by what? F. Now let the element of first set are say 1, 2, 3, and let the say element of set F are say 1, 2, 3, 4, 5, 6. If the element of this first set means set E satisfies some condition, at that time we can say that there is function from set E on set F. So try to understand this condition. So conditions are only on the element of what? Set E. So first condition is every element of set E should be related with some element of set F. So I just understand how many elements are there in set E? Only 3 elements. So we have considered one very simple example. So check whether all the elements are related. Yes, all the elements are related, means first condition is satisfying. And second condition, that every element should be related with one and only one element. First condition, that every element should be related, and second condition is what? With one and only one element of this second set, means set F. So check that one is related with only one element, that is with 2, 2 is related with only one element, that is with 4, and 3 is related with only one element, that is with what? 6. Means our both the condition are satisfying, that every element should be related and with one and only one element of another set. So since both the conditions are satisfying, that's why we can say that there is a function from set E on set F. If there is a function, so then this first set is called as a domain set. So these words are very important. In many example we are observing such type of words, that domain set, codomain set, range set, and this second set is called as codomain set. Codomain set. And the third important word is what? Range set. Range set. Now range set contains those elements of codomain set which are images of some element of domain set. Now here this 2 is called as image of 1, 4 is called as image of 2, 6 is called as what? Image of 3. So which are the element of codomain set which are images? 2, 4, 6. So collect all such element of codomain set which are images of some element of domain set. So set of all such elements is called as what? Range set. So hope the idea about these three definition is very clear to you. Again see here, 2 is called as image of 1, where 1 is called as pre-image of 2. 2 is what? Image of 1, and 1 is what? Pre-image of 2. In the same way, 4 is image of 2 and 2 is pre-image of 4. Is it clear? Now consider one another example here. Let us denote this set say by C and D. Let the element of this first set are say -2, -1, 0, 1, 2, and let the element of this set are say 0, 1 and say 4. Okay, so now I am supposing that let -2 is related with its square, means with 4. -1 is related with its square, that is with +1. Square of 0 is 0, square of 1 is 1, and square of 2 is what? 4. In this case, let us check whether there is a function from set C on set D or not. If our definition of function is satisfying, means we can say that there is function from set C on set D. What is first condition? Every element of first set, which is the first set here C, should be related. So total 5 elements are there, and we can observe that every element is related with some some element of set D. Now what is second condition? Every element should be related with one and only one element. Now observe that minus 2 is related with only one element 4, minus 1 is also related with only one element 1, 0 is related with 0, 1 is related with only one element 1, and this 2 is also related with only one element 4. There is condition only on what? Domain set. There is no condition on the element of what? Codomain set. May be possible that codomain set, any element of codomain set may have more than pre-images, more than one pre-image, but there is no condition on the element of what? Codomain set. Conditions are only on the element of domain set, and domain set satisfies both the condition. Every element is related and with one and only one element of set D. So we can say that there is a function from set C on set D. So these example we are discussing only to understand the definition of what? Inverse function. Last example, let us denote here first set by A and second set by B. Let the element of these sets are say 1, 2, 3, 4. Let 1 is related with say 3, 2 is related say with 6, 3 is related say with 9, and 4 is related with 12. Now in this case also, just simply we can observe that every element is related and with one and only one element of set B. Means we can say that there is a function from set A on set B. Now check that here on this side every element is related with one and only one element, but on this side check whether every element has, or the element which are images has one and only one pre-image or not. So 2 has only one pre-image, 4 has only one pre-image, 6 also has only one pre-image. So such function is called as 1-1 function. Which function? 1-1. इधर के साइड से तो वन ही एलिमेंट से रिलेटेड होता है, लेकिन जो एलिमेंट इमेजेस है उनको अगर एक ही प्री-इमेज है, so at that time we can say that function is what? 1-1 function. So in this case ये साइड से 1 है, लेकिन यहाँ पे 1 को कितने प्री इमेजेस है? 2 प्री इमेजेस, -1 also and +1. 4 also has how many pre images? 2 pre images. So if at least one element has more than one pre-image, at that time it is called as many-one function. many-one, ये साइड से 1 है और ये साइड से many है. Such functions are called as what? many-one function. In this case ये साइड से तो 1 होता ही है according to definition, ये साइड से भी 1 है, means every element has what? One and only one pre-image. So that's why we can say that this is also an example of what? 1-1 function. Now we will discuss about into and onto. Into means what? How many elements are there in codomain set? 6 elements are there. Check whether every element has pre-image or not. Yes, here we can observe that 1 does not have pre-image, 3 does not have pre-image. At least one element of codomain set does not have a pre-image. At that time function is called as what? Into function. एक भी element को अगर pre-image नहीं है, then the function is into, and if every element has pre-image, at that time it becomes what? Onto. In this case all the element has pre-images, so it is onto function. Here also every element has pre-image, so this is example of what? Onto function. So here we have discussed some cases. I am not saying that every case. Just to understand this definition we have considered 2-3 cases of different type of function: 1-1 into, many-one onto, and 1-1 onto. Is it clear? Now we will focus here. Just we have seen what definition of what? Function. We have taken 3 examples which satisfies the definition of function. Now we are discussing about inverse function. Now how to check whether the inverse function exists or does not exist. Now here one function is there from set E on set F. Now we have to check whether the function from set F on set E exists or not exists. When we can say that function from set F on set E exists if the element of set F satisfies the condition in the definition. What is first condition? Every element should be related. अभी फिर से देखो, E से F पे फंक्शन है, अभी हम देख रहे हैं कि F से E पे फंक्शन डिफाइन हो सकता है या नहीं हो सकता. Okay, so now check whether every element is related. No. So here 1 is also not related, 3 is also not related, 5 is also not related, means our first condition is not satisfying. Getting it? So that's why we are not able to define a function from F on E. Consider the second case. In the second case, now we have to check whether a function from set D on set C exists or does not exist. Now check whether element of set D satisfies the condition in the definition or not. How many elements are there? 3. Check whether all the elements are related or not. Yes, every element is related. First condition is satisfying. What is second condition? Every element should be related with one and only one element. So one does not related with one element, it related with what? 2 element. So condition is that every element should be related with one and only one element. C से D पे फंक्शन है लेकिन D से C पे फंक्शन डिफाइन नहीं हो सकता because one is related with more than one element. Now in this case check whether now we are discussing, we are checking whether the function from set B on set A exists or not. Now check that every element of set B is related. Yes, first condition is satisfying. Second is what? With one and only one element of set A. Yes, so here function from set B on set A can be defined, and such function, if it exists, is called as what? Inverse function. If I am denoting this function from set A on set B by f, then the function from set B on set A, if it exists, is denoted by f raised to power minus 1, and it is called as inverse function. Means what we have observed here, inverse function exists only if the first function, means f from set A on set B is what? 1 1 and on 2. In this case only the inverse function exists. In which cases inverse function does not exist? 1 1 into, or 1 1 into, many 1 on 2, or many 1 into, in all these cases inverse function does not exist. When it exists, if function is 1 1 and on 2. So this definition we have to use to understand the concept of what? Inverse trigonometric function. So you should have to know when the function is called as what? 1 1 on 2. If the function is 1 1 on 2, then and then only inverse function exists. So what we have seen here, if f is a function from set A on set B, which is 1 1 and what? On 2, then and then only inverse function exists, and it is denoted by this notation, and it is a function from set B on what? Set A. Now observe the definition. F is a function from set A on set B, which is 1 1 and what? On 2 function. If 1 1 and on 2 is there, then for every element of set B there exists a unique element in set A. So then corresponding to every element of set B we will find a unique element in set A. So that's why we can say that inverse function exists. This defines a function from set B on set A, which is called as inverse function of f, and it is denoted by this notation. So hope the idea about inverse function is clear to you. When we can say that inverse function exists, if the first function f is what? 1 1 and on 2. At that time only we are able to define what? Inverse function from set B on set A, or we can say that inverse function exists only if first function is 1 1 and what? On 2. Using this definition we are trying to understand the concept of what now? Inverse trigonometric function. If the inverse function is clear to you, then and then only you are able to understand the concept of what? Inverse trigonometric function. So now we are discussing about what? Inverse trigonometric function. So first try to understand the result related with what? Inverse sine function. If the result related with inverse sine function, means sine inverse of x, will get clear to you easily, you yourself are able to understand the result related with what? Remaining inverse trigonometric function like cos inverse, tan inverse, etc. Isn't it? So try to understand very carefully the result related with what? Sine inverse of x. So to understand this result, so first let us try to understand the graph of what? Sine function. So this is the graph of sine function. Already you have studied it in your earlier classes, means in 11th standard in detail. So we know that value of sine function lies in between what? Minus 1 and what? Plus 1. Its graph always lies in between minus 1 and plus 1. Means for every value on this x-axis is nothing but what? Real number line. Even y-axis is also nothing but what? Real number line. For every value on the real number line we are getting the value of sine function. That's why here we can say that our domain set is what? Real number. Here this is nothing but domain set in which theta lies, and this domain set is nothing but real number. Now codomain set is what? Y-axis. Codomain set is y-axis. But whether sine function takes the values on whole y-axis or only in between -1 and +1, means image of sine function lies in between what? -1 and +1. Just we can observe from this graph, it lies between -1 and +1, and set of all images is called as what? Range. It's called as range set. That's why here we can say that range of sine function is in between -1 and +1. Later on, let us discuss about periodicity. We know that the graph, every trigonometric function is what? Periodic, and its period is. Period means what? After which fixed interval the graph same values are repeating. So here we can observe that this graph, these values, again this same graph is repeating, means the graph is repeating after which fixed interval? Now consider 2 pi to 4 pi. Take the difference. 4 pi minus 2 pi is what? 2 pi. Here also 2 pi minus 0 is what? 2 pi. So 0 minus here again the same graph is repeating. 0 minus 2 pi means plus 2 pi, means 2 pi is the period, because after 2 pi, every 2 pi the same values are repeating, means we can say that sine function is periodic and its period is equal to how much? 2 pi. Is it clear? Now to define inverse trigonometric function, we should have to check whether this function is 1 onto or not 1 onto. We know that inverse function can be defined only if the function is what? 1 onto. So here from this graph we can observe that what is the image of 0? Image of 0 is 0. Image of pi by 2 is what? 1. Image of 3 pi by 2 is what? Observe the graph very carefully. Image of 3 pi by 2. 3 pi by 2 is what? -1. Image of 2 is what? 2 pi is what? 0. Image of minus pi by 2 is -1. Image of minus pi is 0. Image of minus 3 pi by 2 is +1. Means here we can observe that some element of this codomain set has more than one pre-images. Has more than one pre-images means this function is what? Many one function. Sine function is what? Many one function. And if function is many one function, at that time we are not able to define what? Inverse trigonometric function. So that's why mathematician has decided to select some part of this graph so that the function will become what? 1 onto. So they had decided to consider which interval? Minus pi by 2 to plus pi by 2, so that the function the function will become what? 1 and onto. So in this case, what is the value of minus pi by 2? For minus pi by 2 value of sine is -1, and for plus pi by 2 value of sine is what? +1, and in between minus pi by 2 to plus pi by 2 the values of sines are in between -1 to what? +1, means values are not repeating. Just try to understand. Now we are considering this much part only, in between what? Minus pi by 2 to plus pi by 2. What is the value of sine pi by 2? 1. Sine 0 is 0. Sine minus pi by 2 is what? -1. और 0 और pi by 2 के बीच में भी बहुत सारे नंबर है. 0 degree, 1 degree, 2 degree, infinite numbers are there. And from this graph we can observe that for the values of theta in between 0 to what? Pi by 2. The values of sine functions are in between what? 0 to what? 1. And for 0 to minus pi by 2, 0 to what? Minus pi by 2, value of sine functions are in between what? 0 to -1. ये 0 to pi by 2 के बीच में जो नंबर है उनके वैल्यू 0 से 1 के बीच में आते हैं. And if the values of theta are in between 0 to minus pi by 2, at that time value of sine function is in between what? 0 to -1. That's why we can say that this function becomes 1 onto if the function is defined on which interval? Minus pi by 2 to plus pi by 2. That's why mathematician decided to select this interval, and they define this function as sine function from set A on set B. Set A they have decided what? Minus pi by 2 to plus pi by 2, and the values lies in between what? -1 to +1. So this will be your domain set, and this will be your range set. Is it clear? So now if we are considering this function, at that time from this graph we can verify that the function becomes what? 1 and onto. And if the function becomes 1 and onto, then inverse function exists. and if this function is from set A on set B, then inverse function is defined from what? Set B on set A. So this will become set B and this will become set A, and this, in this way we are able to define what? Inverse function of sine. If we are selecting this much part only, if the sine function is defined in between what? Minus pi by 2 to plus pi by 2, at that time sine takes the values in between minus 1 to what? Plus 1. That's why this function becomes 1 1 and 1 2, and that's why it becomes possible to define inverse sine function. Getting it? So that's why inverse sine function exists if the sine function is defined in this form. Okay, then this x takes the values in between what? For this, now we are discussing about inverse function. This is the graph of inverse function, sine inverse function. So here x takes the values in between what? Minus 1 to plus 1, and theta takes the values in between what? Minus pi by 2 to plus pi by 2 in case of what? Sine inverse. And if we are considering the value of sine inverse which lies between minus pi by 2 to plus pi by 2, such values, means such values of theta are known as principal values. Again, try to understand value of sine inverse of 1 is equals to, chalo, sine inverse key value, this is the graph of what? Sine inverse. Its value is equal to 1 at what? Pi by 2 also. Its value is 1 at what? 5 pi by 2 also. Again we are getting different result which satisfies this condition, but only if we are considering the values which lies in between what? Minus pi by 2 to plus pi by 2, at that time only such values are called as what? Principal value. Means if theta is known as principal value if it lies in between minus pi by 2 to plus pi by 2. Getting it? So these are some ideas about sine inverse of x. What we have seen, its domain set is what? Minus 1 to plus 1, and its principal value or range is in between what? Minus pi by 2 to plus pi by 2, and if theta takes the values in this interval, at that time such values of theta are called as what? Principal value. Means if question is asked to find out principal value, infinite number of values are there which satisfies the given inverse trigonometric function, but we are considering the values of theta, such values of theta which lies in between this interval, at that time only that value is called as what? Principal value. Again let us consider another example. Sine inverse of 1 by 2 is the value of what? 30 degree, means pi by 6. This value belongs to this interval, so that's why we can say that it is what? Principal value. Means if the value lies in between minus pi by 2 to plus pi by 2 and satisfies given inverse trigonometric function. अब ये plus 1 by 2 जो है 1 by 2 यहाँ पे आएगा, तो यहाँ पे भी हमें एक सोल्यूशन मिल रहा है, यहाँ पे भी एक सोल्यूशन मिल रहा है, यहाँ पे भी एक सोल्यूशन मिल रहा है, बट we are considering only the values in between what? Minus pi by 2 to plus pi by 2, then and then only they are called as what? Principal values. So hope the idea about principal values are very clear to you. So if the value lies in this range, at that time it is called as what? Principal value. Okay, so now try to understand this note. Value of sine inverse of x is equal to x, and sine inverse of sine y is equals to y. We are trying to understand this important result considering one simple example. Similar type of result we will get in case of remaining inverse trigonometric function also. So try to understand. We are considering one very simple example. So let us consider here pi by 4. What is the image of pi by 4 under the function sine? We know that sine pi by 4 is 1 by root 2. Means what result we have got here? Image of pi by 4 under the function sine, it is denoted by this notation. Sine pi by 4 is equals to what? 1 by root 2. Now here if we are defining inverse function is denoted by what? Sine inverse. So what is the image of 1 by root 2 under which function? Sine inverse is pi by 4. Means here we can say that sine inverse of 1 by root 2 is equal to what? Pi by 4. Okay, so now let us simplify this result, which implies that Now observe that here sine, keep it as it is. I am not disturbing to sine. So here pi by 4. Can I replace this pi by 4 by its value? What is the value of pi by 4? Sine inverse of 1 by root 2. So just simply I have replaced pi by 4 by its value sine inverse of 1 by root 2. Keep the right hand side 1 by root 2 as it is. Okay. So now if I am considering denoting this number by x, means this number also becomes what? X, means what result we have got here? Sine of sine inverse of x will be equals to x, means sine of sine inverse of x will be equals to x. This property we are trying to understand with the help of this simple example. Now try to understand the second property. So from this implies that, keep this left hand side, in the left hand side sine inverse, keep it as it is, 1 by root 2. What is the value of 1 by root 2? Sine pi by 4. So replace it by sine pi by 4. Keep the right hand side pi by 4 as it is, pi by 4 as it is. If I am denoting this number by y, means this will also becomes y, means what result we have got here? Sine inverse of sine y will be equals to what? Y. In this way we have got the second important property. These properties we are applying while solving the examples. Okay, again we are studying many another properties. Now here this value of x lies on what? X-axis. So x-axis means in between what? -1 to +1, means value of which function? Sine function lies on x-axis, and this is the graph of what? Sine inverse, which lies on what? Y-axis. So means value of sine inverse we have denoted by y, which lies on what? Y-axis, and means which values? Theta, values of theta lies on y-axis. That's why here instead of theta here we have denoted by what? Y. So these are some very important result related with which inverse trigonometric function? Sine. See, if the concept of sine inverse of x is clear to you, then easily you are able to understand the result of what? Second means inverse cosine function. So now first we will discuss the graph of this function. So already you have studied about this graph in class 11th also. So in this case we can observe that this function is periodic, and if you will observe the graph here, so whatever may be the value we are getting here, so again same value are repeating. So first we are trying to find out domain of this cosine function. So here we can observe that whole real number line, means x-axis, is its domain, because for every value on x-axis we are getting the value of what? Cos here. So we can say that whole real number line is the domain set, and y-axis is what? Co-domain set. But cosine means cos takes the values only in between what? -1 and +1. That's why here we can say that range is nothing but in between -1 and +1, and this function is what? Periodic. And let us check what is the period of this function. So we can observe that, see, observe this graph. This again the same values are repeating, means from 0 to 2 pi, then 2 pi to 4 pi we are getting same values, means here 2 pi minus 0 will be equals to what? 2 pi. That's why we can say that its period will be equals to 2 pi, because after 2 pi again we are getting same values. Now let us discuss about this function, whether this is a 1 function or many one function. So here we can observe that, let us consider +1. +1 is the value at what? 0 also, again at 2 pi also, again at 4 pi also, means at infinite number of points image will be what? +1, means image of 0 is also +1, image of 2 pi is also +1, image of 4 pi is also +1, means we can say that 0 is the image of at many numbers. That's why we can say that this function is what? Many one function. And if function is many one, we know that we are not able to define its what? Inverse function. So that's why mathematician had selected such interval so that the function, this function will become what? This function will become 1 on 2. So here in the last case, means in case of cosine, which interval we have selected? -pi/2 to +pi/2. In this case, see what will happen if we are selecting this interval minus pi by 2 to plus pi by 2. If you'll observe the graph is going from 0 to 1, and again same values are repeating from 1 to what? 0. Means here 0 we are getting at 2 point. यहाँ पे कुछ तो भी number होगा, वो number भी कितने जगहों पे मिल रहा है हमें? 2 point. Means again the function is become what? Many one. So in this case we are not able to select this interval minus pi by 2 to what? Plus pi by 2. That's why mathematician had selected which interval? 0 to pi, so that the function will become what? 1 1 on 2. Now for 0, what is the value of function? Plus 1. And at pi, what is the value of function? Minus 1. And in between 0 to pi, the graph is moving from what? Plus 1 to minus 1. Means values are not repeating here. Means we can say that function will become 1 1 and on 2. Means for every value of x on this x-axis in between 0 to what? Pi, the values are moving from what? Plus 1 to what? Minus 1. Means values are not repeating, means function becomes 1 1. And why we are saying that on 2? Because for every value on this x-axis we are getting the values of y, isn't it? So that's why we can say that function becomes 1 1 on 2. And if function becomes 1 1 on 2, at that time we are able to define inverse function. That's why here if you are considering cos as a function whose domain is what? 0 to pi, and its range is in between minus 1 to plus 1, 0 to pi, and range is in between what? Minus 1 to what? Plus 1. If we are defining the function in this form, then it becomes 1 1, it becomes 1 1 on 2, and if the function becomes 1 1 on 2, we are able to define what? We are able to define inverse function. We can observe that here inverse function is, if this function is from a to b, then its inverse function is from b to a. Means this function will become here domain, and this function will, this part will become what? Here range. This interval become domain, and this interval become what? Range. So all these things, such type of things already we have discussed in what? Sine, cos, sine inverse also. Similar type of these important notes we are getting in cos inverse also, and already we have discussed how we are getting such result. So we are not repeating again those steps. The method which you have used or method which you have seen in case of sine inverse, same method is applicable in what? Cos inverse. So remember these properties can be satisfied in all the cases, means for all inverse trigonometric all 6 inverse trigonometric function. What this property says? Value of cos inverse of x is equal to x, and value of cos inverse of cos y will be equals to what? Y. So these are some idea about what? Cos inverse. Now here this is the graph of cos, and this is the graph of what? Cos inverse. If you'll observe the graph here, whatever may be the domain set is there. What is domain set? 0 to pi. Now it will become what? Here range set 0 to pi. That's why here we have written range set is equal to 0 to pi, and here domain is what? Range is what? Minus 1 to plus 1, minus 1 to plus 1. Here minus 1 to plus 1 will become our what? Domain. So minus 1 to plus 1 will become domain, and range will become what? 0 to pi. And if the value of theta satisfies the given inverse trigonometric function and lies in between 0 to pi, at that time it is called as what? Principal value. So these are some important results related with our second inverse trigonometric function, that is cos inverse of x. So well, now let us discuss about the next trigonometric function, that is tan. First we will just observe the graph of this tan function. So here we can observe that same values are repeating, means it is what? Periodic function. So every trigonometric function is what? Periodic. But now here from this observation we can observe that at value of minus pi by 2 the value goes toward what? Infinity. At pi by 2 this value goes toward infinity. At 3 pi by 2 this value goes toward infinity. Means graph moves toward infinity. Infinity means what? Undefined value. Means where the value of tan does not exist, it does not exist at odd multiple of pi by 2. Here what is multiple of pi by 2? Minus 1, here plus 1, here 3, 5. All these are what? Odd multiple of pi by 2. That's why we can say that value of tan exists on whole real number line, except at which point? 2n means what? even number. 2n means even number. If we are subtracting 1 from even number, it will become what? Odd. And odd multiple of pi by 2, where n belongs to z means n is integer. Means at odd multiple of pi by 2, we can say that value of tan does not exist. So this symbol means difference, means value of tan exists on whole real number line. Difference means except at what? Odd multiple of pi by 2. And here range is what? Whole real number line with whole y-axis. Y-axis is nothing but our codomain set, and tan takes the values from what? Minus infinity to plus infinity. On which axis? Y-axis. That's why we can say that here range is nothing but what? Range is nothing but whole real number, means whole y-axis. X-axis is also real number line, y-axis is also real number line, and tan takes the values on whole y-axis. That's why we can say that range set is what? R. In case of sine and cos, we have seen that sine and cos takes the values only in between what? -1 and +1. That's why here we can say that range set is in between -1 and +1. And here period. What is the period? Period means same values are repeating. If you will observe here, minus pi by 2 to plus pi by 2. This length will be pi by 2 plus pi by 2 means pi. Pi will be the period of this function. Now we are discussing inverse trigonometric function, means tan inverse of x. Now we have to select such part or such interval from this graph so that this function will become what? 1 1 on 2, isn't it? So that's why if you'll observe, and generally we are selecting which interval which is very close to what? Origin. So here if you'll observe here, if we are selecting this interval minus pi by 2 to plus pi by 2, graph is moving from what? Infinity to minus infinity, or in other word we can say that minus infinity to plus infinity. Means in this interval this function becomes what? Means if we are selecting this much part only, at that time we can say that function becomes what? 1 1 on 2. That's why if we are defining the function tan in this interval minus pi by 2 to plus pi by 2 on real number line, means y-axis is nothing but what? Real number line, then we can say that function becomes 1 1 and what? On 2. And in such cases we can say that inverse function exists. If this function is from set A on set B, then inverse function is from set B on set A. Means here domain set will become R and range set will become what? Minus pi by 2 to plus pi by 2. So these are some idea about which inverse trigonometric function? Tan inverse. Now let us discuss about next trigonometric function, that is cot. So here cot takes the values on what? Whole real number line. If we will observe here, its same values are repeating, means we can say that this function is what? Periodic. Means it is many one function. Its value does not exist at what? Minus pi, its value is going toward infinity. At 0, its value is going toward infinity. At pi also its value going toward what? Infinity. Means at minus pi, 0, pi, 2 pi, means what are the multiple of pi? Are integer. That's why we can say that this function takes the values on whole real number line except at integral multiple of pi. N is nothing but what? Integer. And its range is what? Whole real number line. So means y-axis is also what? Whole real number line, and it takes the values from infinity to minus infinity. That's why we can say that range is here whole real number line R. And if you'll observe its period, so its values are repeating after this fixed interval. What is the length of this interval? 2 pi minus pi will be equals to pi. Here pi minus 0 will be equals to pi. That's why here we can say that period of this function is what? Pi. Now we are discussing now we'll focus on our important article. Now we are we are observing that in which interval this function will become 1 1 on 2, so that we are able to define what? Inverse trigonometric function. Now which is the interval very close to 0, that is 0 to pi. In this interval its value are moving from what? Infinity to minus infinity. Again here infinity to minus infinity. This is the interval very close to origin. So that's why if we are defining on this interval, function will become what? 1 1 on 2. That's why we are defining this function on which interval? 0 to pi. open interval 0 to pi, because 0 is not included, pi is also not included, because at this 2 point value is what? Undefined. So that's why open interval 0 to pi on real number line, because it takes in this interval also it takes the values from what? Infinity to minus infinity, means it takes the values on whole real number line. Y-axis is also what? Real number line. So if we are considering this much interval, we are saying that in this interval this graph becomes, or function becomes 1 1 on 2. So inverse function exists. If this function is from set A on set B, then the cot inverse will be from B on what? A. So for this function, our domain is what? R, and our range set is what? 0 to pi. Now let us discuss about next very important function, that is sec. Now first we can observe that again the graphs are what? Repeating, values are repeating, means we can say that the function is periodic. Where its value does not exist, its value does not exist at what? Minus pi by 2, plus pi by 2, 3 pi by 2, again 5 pi by 2, means these are nothing but odd multiple of pi by 2. That's why we can say that sec takes the values on whole real number line except at odd multiple of what? Pi by 2. Now it's now we are finding its range. Now we will observe that which part is not included, or in which part this graph does not enters. It does not enters, or this graph does not lies in between what? Minus 1 to plus 1. Means this graph means sec function takes the values on whole real number line except in which interval? Minus pi to plus pi. That's why we are saying that it takes the values on whole real number line except in which interval? Minus pi to plus pi. And here also just by observation we can say that this function is periodic, and easily we are able to find out its period. What is its period? 2 pi. But now we are defining what? Inverse trigonometric function. So such interval very close to origin in which the function will become what? 1 1 and on to. So observe, this will be y-axis. So observe, this graph is moving from 1 to infinity, in between what? 0 to pi by 2, and from pi by 2 to pi it will moving from what? Minus infinity to minus 1, means values are not repeating here. So that's why we can say that in this interval the graph becomes what? 1 1 on 2. So that's why if we will define this sec function in which interval? 0 to pi except pi by 2, difference pi by 2, because at pi by 2 it is moving toward infinity, or it is moving toward minus infinity, means we can say that value of sec does not exist at what? Minus at pi by 2. That's why we can say that here its domain is in 0 to pi except pi by 2, because at this point value of sec is what? Infinity. That's why we are excluding pi by 2. And here whole real number line, it takes the values on what? Whole real number line except which interval? Minus 1 to plus 1. So if we are defining the function in this way, it will become 1 1 on 2, and that's why we can say that inverse function exists. And if this function is from A to, if this function is from set A on set B, then inverse function is on what? Set B on set A. Similar result we are getting in terms of what? Cosec also. So again observe the graph of cosec, where the value of cosec does not exist at 0, pi, 2 pi. That's why we can say that value of cosec exist on whole real number line except at what? Integral multiple of pi. And here we can observe that here range will be whole real number line except which interval? Except interval minus 1 to plus 1. In this interval that graph does not enters or does not lies. So and its period is also what? 2 pi. Now we are finding such interval in which this function will become what? 1 1 on 2. So observe here, this will be what? Y-axis, and here we can observe that this graph, observe the graph in between what? Minus pi by 2 to plus pi by 2. Here it from minus pi by 2 to 0 it will moving from what? Minus 1 to infinity, and here in this 0 to pi by 2 it is moving from infinity to plus 1. So here it will be negative part, here it will be in positive part, means we can say that value does not repeats, means the function becomes what? 1 1 on 2. And that's why if we are defining the function in between minus pi by 2 to plus pi by 2, we can say that function will become 1 1 on 2, means its inverse function exists. If this function is from set A on set B, then its inverse function will be on what? Set B on set A. That's why this will be its domain and this will be its what range, which already we have written in this table. So all these are the important result related with what inverse trigonometric function. So in the next video we are going to prove some very important properties of inverse trigonometric function. Properties are nothing but formulas for us. Already we have seen this property, that sine of sine inverse of x is equal to x or sine inverse of sine y is equal to y. Similar conditions are satisfying in case of all inverse trigonometric function. So in the next video we will prove our very important properties. Properties are the theorems